So hopefully you guys are semi-far into this problem. We're just going to run through it real quick. Give Chi-Chi 1 second. Wait. All right, I'm just going to draw a picture, okay? All right. So we have Cody running north, which I'm going to call Y. We have Cassie running west. I don't know why. And then we have the distance between them, which I like to call Z. You use whatever variables you like. Okay? Let's go ahead and choose a thicker. Okay. What equation is going to link all these together? Anthony, what do you think? Pythagorean theorem. It's on the Pythagorean theorem worksheet, and it used the Pythagorean theorem. This is crazy. All right. So yeah. So we're going to have x squared plus y squared equals z squared. Remember, we said label everything that's changing with a variable. Since all the sides are changing, they all get variables. Okay? Do we know how fast x is changing? X is changing at 5 miles an hour, and y is changing at 7, and they're asking us how fast z is changing. Cool? So we know two rates of change, which means we can derive this, and that we're going to be fine, and we're going to have one unknown, which will be dz dt. So when you derive it, just like we did yesterday, we get 2x times dx dt plus 2y dy dt equals 2z dz dt. So, what do we know here? Let's plug in all our variables. What's x? What's x, Chi-Chi? What is it? 10? Yeah. Sounds good. What's dx dt? 5. It is 5. That's not 5. But it's all coming back to me. Plus, what's y in this case? 14, because Cody is just flying 7 miles an hour. My gosh. And dy dt is 7. Now the problem is we don't know z. Am I find that yet? Okay. So how'd you get that, Chi-Chi? Yeah, man, we're going to use, it's not 25 plus 49. You got to plug in the lengths that they are right now, okay? You're plugging in the rates of change. So, cool. So we got to plug in 14 for x and 10 for y. All right? Or the other way around. 14 for y, 10 for x. But when you plug in 10 for x and you square it, you get 100. And then you get 196 when you square 14. And that has to be z squared. So z is the square root of 296, which we can simplify that a little bit, but I'm going to wait till the end here. Okay? So I'm going to put that right in here. Is everybody okay with that? Any questions? Again, we had to go and find the missing variable. We all right? Okay. And now the only thing that's left to find, the only thing we don't know on this equation, which we're not supposed to know, is dz dt. So just solve for it. So on this side, we're going to have 100. Plus, on this side, we're going to have 14 times 14, which is 196. And then we're going to divide that by 2 square roots. 2 square roots. Oh my gosh. Of 296. And that's what dz dt is going to be. Okay, and we got to remember units for this, and we got to simplify this down. So it turns out that 100 plus 196 is really 296. If you think about it like that, like this is really a 296 up here. And when you divide that by the square root of 296, you get the square root of 296. So this is what we're working with. How do I simplify down that square root? What goes into 296 that we're sure has a nice square root? 6. Well, 6, we can think 64 definitely goes into 296. All right? 4 goes in, what, 74 times? So this becomes 2 root. Why do I know it's 74? How many times 4 go to 100? 25. So 4 should go into 300. 75 times, but 1 less than that, so 74. Okay? So it's 2 root 74. That makes sense? Yeah. And then the 2's cancel, which is nice, and we get square root of 74. And I don't think square root of 74 simplifies down at all, right? What is that, 37 times 2? Yeah, so it doesn't work out for us. So we get the square root of 74. What are the units on that? That is miles per hour. Okay, and that's just, again, at that exact moment in time, how fast the distance between them is growing. That's all we just found.